Some quadratic equations can't be solved by factoring, and in that case we can use the quadratic formula. Remember, the quadratic formula tells us the roots or the zeros or the x-intercepts of the parabola. It also tells you the solutions. The quadratic formula tells us that we have x equaling, so it gives you x values. Remember, they're x-intercepts also, so we're going to say x. And then we have x equals negative, so the opposite of b, plus or minus. Remember, there's two answers usually. The square root of b squared minus 4 times a times c, all of that divided by 2 times a. So we're going to be using the calculator a lot, but we have to write down what a, b, and c are. So in this problem, a is, I'm going to use green. A is 8. Remember, a is just the number in front of x squared. You don't include the x squared. That's wrong. It's just the coefficient in front. Because I have, remember, the standard form of a parabola is ax squared plus bx plus c. So a is just the number in front of x squared. B is the number in front of x. So b is negative 5. And c is negative 2. It's just the number. And now I can use the quadratic formula. So I'll use this. So x equals negative parentheses b, that's negative 5, negative 5, that will change to a positive, plus or minus the square root of b squared, which is negative 5 squared, minus 4 times 8 times negative 2. Right? That's 4 times a times c, all divided by 2 times a, which is 8. Now I'm going to simplify. Remember, I plug this part into the calculator. You can do that all in the calculator. This becomes positive 5 plus or minus the square root of 25 minus 4 times 8 times negative 2. Lots of people, way too many people, forget the negative signs. I'm just going to plug all of this into the calculator. It's hopefully it's simple for you as well. 8 times 2, that's 16. So I'm going to plug all of this into the calculator and see what happens. And I get 89 underneath the square root. I still have the plus or minus, the 5 and the 16. We're going to take this all the way down, so I need to do the square root of 89. How do I do that? You just do it in the calculator. It's not a perfect square, so yeah, you have to do it in the calculator. Or you can estimate it some other way, but we're just going to use the calculator. So square root of 89 is 9.43, I'm rounding, 434, plus or minus 5 over 16. And then I do the plus or minus. So I do 5 plus 9.434 divided by 16. And I also do the minus part, 5 minus 9.434 divided by 16. So I'll do this part first, plus 5, that's going to equal, I mean, you don't have to write all of this down, you could do this in your calculator, but I'm showing you, so I'm going to write it down. So I get that, and then I'll divide it by 16, and I get 0.902, so that's one of my x-intercepts. And my other x-intercept, so that's x equals, that's one of them, and then I gotta have this part. So I'll do 5 minus 9.434. 5 minus 9.434. That's negative 4.434, and I'm dividing that by 16, so divide 16 equals. That would be negative 0.277. And there we go. That we have the two answers. Those are our x-intercepts. So the graph of this parabola, if we were to graph it, we would have, I guess, there's 1, negative 1, 0.9, that's really close to 1, so I'd say maybe 0.9, 0.9, that's right there, so that's this x-intercept. The the other x-intercept is negative 0.2, that's probably something like that. And I know that this parabola, it opens upwards because A is positive. If A is positive, the parabola opens upwards, so it looks something like that. But it didn't ask us to graph it, so we didn't have to graph it. Those are the answers. That's how you use the quadratic formula. Remember, the quadratic formula tells you the roots, the zeros, or the x-intercepts. You can always use it for any quadratic. It's helpful when you can't factor to use the quadratic formula. It's helpful. Something that I wanted to remind you of was if you get 0 on the inside of here, then you only get one x-intercept. You only get one answer. If you have a negative inside here, like this was a negative 89, then you would get no x-intercepts, so it would cross the x-axis 0 times. Yeah, there we go.